Now that we've seen the logistic regression model and we understand it in quite a bit of detail, let's give a quick overview of what learning means for this model. Although in the next module, we're going to go into quite a lot of detail of the learning algorithm. This is just a little primer, a teaser for what's coming in the next module. Now we're going to start from some data, and that data has inputs x and outputs either +1 or -1. As we said, we're going to split that into a training set and a validation set. And from the training set, we're going to run a learning algorithm that will output the parameter estimates W hat. And those W hats are going to be plugged into the model to estimate the probability that an input sentence is either positive or negative. And of course, we can use the learned model to take the validation set and estimate how good it is, what the quality metrics are, what the error is. Now, to find the best classifier, we're going to define a quality metric. In this case, the quality metric is going to be called the likelihood function. So for every possible parameter set of coefficients W, for example, W0, W1, and W2, we're going to be able to score it according to L of W to figure out how good it is. So for example, if I take this data set of pluses and minuses and learn the line shown in green, we might get a particular likelihood. So for example, if the parameter W0 is 0, W1 is 1, but W2 is -1.5, the likelihood might be 10 to the -6, pretty small. These numbers actually tend to be pretty small. For this alternative line, where W0 is now 1, W1 is still 1, W2 is -1.5, the likelihood function is a little better, 10 to the -5 instead of 10 to the -6. But perhaps for this best line over here, where W0 is 1, W1 is 0.5, and W2 is -1.5, you get the best likelihood, 10 to the -4. And so we would like an approach that will actually search for the possible values of W to find that best line. And as we'll see in the next module, we'll use a gradient ascent algorithm to find the set of parameters W that has the highest likelihood, the best quality.